So hello and welcome. That is a weird picture of me. This is my contact info. If anyone wants to shoot weird questions to Twitter, I'll try to answer them as best as I can. Yeah, let's get some Git going. So these are the foundations of Git. There are certain types of objects. So we have the, don't worry, this is doesn't take too long. Then you get more into the fun stuff. So we have the blobs, which is the puzzle piece here. That's where all your stuff goes, your files. Files end up in a tree. So this is your equivalent to a directory or a folder or whatever you want to call it. And a commit has one tree that is the root of that commit. And then you have a ref. Usually they are called branches. And in my graph here, there's an arrow. So it looks something like this. We have a master branch pointing to a commit, pointing to a tree that has some other trees with some blobs. So this is the file hierarchy of a particular commit. And then we have one other commit, has a parent commit of this initial one, and so on. So at the develop branch, we point to this particular commit, and this points all the way back to the start of time. So one thing about these building blocks, the blobs, the trees, and the commits, these are all stored in the Git object using their cryptographic hash. So if you change any files that's related to this, you're going to get a new object ID. So because of that, you cannot change any of these objects without the change being cascaded all the way up. So if you change a file, you're going to have to change the tree and that commit and so on. So, however, the refs are not as they are easier to change. So if you need to make a change here, instead of changing here directly, we can make a new copy of this world and then develop to point here. Also, feel free to turn off devices and whatnot. But yeah, I'm certainly not the one to throw the first stone in that regard. So yeah, so if we were to make this change, we create a new tree and then we repoint the branch to point here. So these objects, even though they're not pointing anywhere, they're still in the background. So if we want to retrieve them later on, for whatever reason, they're still there. And they're typically there for give or take 90 days. After 90 days, they might get cleaned up by garbage collection. But anything you've done in the last 90 days, roughly speaking, should still be in your Git tree. So I'll bring up. So general note, if at any point you have any questions about anything I'm covering, feel free to stop and ask questions about it. For one, I'm trying to help you. All of this is stuff that I have already done myself. So if you have anything that I'm not covering that you would like to get some insights into, I'll try to do my best to answer that. So imagine we're on a master branch of sorts, and we add some. Missing files. So we add 3 files, and then I'm trying to remember what this actually does. Oh, so what we're doing here is we have some files that we missed to add in the first place. So so something like this. We have, for instance, README. We have some sort of app. So since we're in a JavaScript meetup, why don't we do some JavaScript? And I'm sure there are lots of people who frown upon the use of war, but whatever. So git status here, we see that we have 2 files. So we add this README file, we commit README, and an awesome app. But as you can see, there's still this untried file that we forgot to add. So we could make another commit and look stupid, or we can do git add on this one file and do git commit amend. That way we can, instead of doing a new commit or have two commits that way, we fix up the one we just made. So no one has to know that we screwed up, which in my case is good. So it's all in one commit. Chances are, so this app is going to drive me crazy before the night is over.
When is it too late to amend?
Now that is one interesting question, and that I'm guessing you're gonna what you allude to is going to be the push factor. When you push something and other people are aware of what you've done, it might be slightly rude to amend stuff and push it over, because you might people might get mad at you, and rightly so. But that said, yeah, it's never too late per se. You can always get away with it if you communicate it well enough.
Is there a record that you did it?
That you what?
Did they add?
Yes. You have a ref log, for instance, which I'll come back to later. But yeah, this will only be visible to those. So if you push this, they would only see what you push. But if you amend it and don't push any of the older stuff, they only see the top stuff, so to speak. So if you don't share your local Git folder, no one has to know that you cleaned up after the fact, or yeah, cleaned up before you pushed.
So git amend doesn't create a new commit?
Yeah. So again. So let's go back to this. So what we do here is, imagine this commit. So what we do when we amend is we do something like that, but I can't. Okay. So we start here. So commit amend would do something like that. So it would create a new tree structure and repoint the ref. It would be a new commit. And they would have all the changes that you wanted to. Does that answer your question?
Yeah.
Perfect. But yeah, roughly, you're going to see all of your commits that you made. Now another one that happens more than I like to admit to. So imagine we do some stuff. And we added a file that we don't want to be there. For instance, so we take our awesome app. We have some config file that has an awesome password. There might be some turtles here. Oops, I don't know what happened there, but it got there. So even though you should never commit your passwords, if you do, oops. Don't do it. So in this case, I actually didn't because I didn't have the file, or did I? I guess I did. So that's what you should never do. You should never commit your passwords because people might take advantage of you if you do. So now we're at a state where I have this file, and I don't want it to be in my repo anymore. Git rm cached, and then name of the file. We'll remove the file from Git, but the file will still be there. So if you need the file for whatever your app is doing, you still have the file, but the file is not stored in Git anymore. So,
say you do a few more commits and then you're like, oh shit, password is a few ago. There's like a long command for it, but like, is there any better way to do it?
Yes, there's actually a slide coming up for that. Again, this is a lot of stuff. It's a good question, and I've done it in the past, so yeah. I'm trying to cover all of that. So I think that is actually what happened. Oh, so this is how you can kind of avoid these kind of mistakes. Say, for instance, you have this config.js file. So one option is to create a Git Ignore file. Git Ignore, and say config.js should never be in there. So that way, even if you do a git add dot, which you should never do, for one, C shell will prevent me from doing it. So even if you do that, you only add this ignore file, not the actual password file. But if you if it is a file that has to be there, like that, and then what you do is you take the file and change this to the actual passwords. So even though this file, if you put it in Git Ignore, Git status. So Git Ignore does not work on already tracked files. So if you were to do a git add dot, which you should never do again, you see that your password is in there. There is a way around that. It's called. What was that?
Could you clear off the terminal so it goes to the top?
Oh, like that?
Yeah.
Sorry. Let's not do that. Is that how far down can you read? Okay. So where was I? Oh yeah. So Git Ignore only deals with already tracked files. If you have a file that is, I should say, Git Ignore only deals with untracked files. If you have a file that is tracked, like that, and you don't want to commit that by accident, there is a command called, and this is, I'll bring this guy up again, like that. For one, the Git Ignore. If that doesn't work, there's a git update index assume unchanged. And that will tell Git that no matter what I do to this file, that file is not seeing any changes to it. So you can go about. Is it too low still?
Well, it's the slides. It's the place where the screen is, not your phone.
Ah, okay. So, yeah, even though we change.
Is that sticky for that file, or is that?
It's sticky for that file, yes. So even if you change here, Git doesn't care. It's like the new Honey Badger. So those files that are already in the repository, but you need to make some changes to, that is a good use case for that, especially if the file doesn't update much. If you need to bring in up stuff from it.
Quick question about the assume of change.
Yes.
If somebody else makes a change to that file, you're going to get a merge conflict, right? You have made changes as well.
I think it's going to say something to the effect of dirty tree or something like that. So yeah.
You have to either commit your changes
Right.
or
You need to undo that thing, which is probably what you would do in that case, is to say update index no assume unchanged. Config.js, and then it's basically undoes that. Yeah.
quick question. When you said that when you remove the Git Ignore file,
Yes.
did you say that because Git has already recorded the content of the Git Ignore file, it will still ignore these files? Is that what you said?
No. What is going on there is so Git Ignore, so there's while we're on that topic, there's a Git Ignore that you can put in any file inside your Git folder. There's also a repository specific one called Git info exclude. There's also, you can tell it to have like a global ignore file as like that. So core excludes files. So you can have a user global ignore file. So I don't think I have anything of importance in mine, but you can have one. So we ignore pants. So I wonder how long I've been ignoring that. Quite a while. To answer your question, either of those files, what they will do is that they will prevent Git from adding any new untracked files that match any of those.
I rephrase the question maybe I want
Yes.
to hear is that whenever you do an add, is the .git ignore file read each time?
Yes.
It does, okay.
Yeah. Yep. So somewhere deep down we have new slides. So imagine we're doing something bad and we want to just get rid of whatever that commit is. This app is going to be the death of me. So we have this, we committed this commit E here, and we want to just get rid of it. We did something very stupid. Let's imagine that, for instance, we did something, we committed it, we went to lunch, and then we realized that's stupid, let's do it over. So to get rid of the top commit, there's this Git Reset hard with a head caret. This will undo. It will do three things, I guess. It will put the index back to the head caret. It will put the working directory back to it, as well as the update the ref to point to it. If those words made no sense at all, there's a very good video that by I want to say Scott Rochon or something, one of the GitHub people. It's called the Tale of Three Trees, I want to say. So he explains it a lot better than I do. So. Tale of Three Trees, yeah. So if you want to know more about that, check that out. So it goes into detail what reset does versus checkout. So it's a good watch. But for this, what it will do is effectively undo whatever you did in the last commit. So if we say, let's unassume this. Somewhere I have a no assume unchanged. Okay. So let's say I actually committed my password. And I go to lunch and I realize I committed my password. I should never do that. Git reset hard head caret. I think my Z shell is going to complain with the caret. So you can also do tilde. Those two are equivalent in this case. The caret will give you the first parent commit, whereas the tilde will do the same when you have one. So they start to diverge when you have like that, for instance. In the case of the caret, this will give you the second parent. In case of a merge commit, it will give you the right side of the merge, whereas this will give you this second parent on the left side. So tilde 2 is equivalent to double caret like that. So if you want to go 10 commits back, you can either stack up your carets or be smart. What? So that's how you do that. I actually did do it, right? So now, yeah, so now my password is not there anymore. So that's how you get rid of the top commit. But now imagine we were a lot more stupid before we went to lunch. And we started working on something, we committed the password, and then we did more stuff. So I have, so I want these E and F commits to be on top of C rather than D. So I want this D commit to completely go away. And like anything in Git, there's usually 3 or 4 ways to do something, some of which are more easy to do than the others. So this is my my favorite way to do it. So Git Rebase, you say D, which is where the top or rather the start of the stuff that you want to work with. So we say D, meaning anything that is coming after D. So in this case, E and F. We want those to, instead of being here, we want them to be applied on top of the parent of D, or C in this case. So you can either say D caret here, or you can say C. They will result to the same thing. So if we were to do this, so add back my password. And then we start. Because I do that a lot, I'm going to say git add p. Whenever you have the p flag available to you, you should use it. It's usually there for a good reason. So git add p will let you interactively take hunk by hunk and say yes or no if you want to stage this. Also applicable to checkout, to stash, and to log, and a few others. Basically, it means you get some sort of patch that you can work with. So in this case, I want to stage this. Now I can do this command again. So now we're at this state, like here. We're at the D state. Now we need to do the additional commits. So let's do a few here. We have 2 commits. They say, pretty please, do not commit your passwords. And I did it anyway. So what we need to do now is we have this commit, the oops commit. And this is what we put in. This goes instead of the D in this chart here. Here. So this long nondescript whatchamacallit goes here. So you want to rebase those and put it on top of the parent of that, which will have the end result of now I no longer put my password in there.
You said that it also works for a stash. Does it also work for a stash pop? So can you do
For
like a partial stash pop?
what was that? Sorry.
So you said that the dash B works for a stash.
The git stash, the stash command, yeah.
Does it also work for the stash pop to pop out of the
Oh, I do not believe that you can do P for that. It's possible, but let's actually check that. So, for those who are not familiar with stash, it's a way to stash stuff. So now the change is nowhere there anymore, when you can stash pop and get it back. So the question is, does stash pop work with a P? No. So that is too bad, but it does work with checkout. So you can interactively, what was the right word? Revert partial changes, or undo. Undo is probably a better word because there's a revert command that does something completely different, really.
One question: any of these deletes or rebases are creating havoc if you already pushed it?
Correct. So if you do this, make sure that you haven't pushed or shared anything with this with anyone yet.
Can you set a command common to GitLab as well?
Well, so GitLab is just a repository. So GitLab is this is unrelated to GitLab or GitHub or any of those. Was that? What was your question? I guess. Yeah. What was your question? If this works with GitLab?
The commands that you're using are the same with GitLab?
Yeah, yeah. GitLab or GitHub or any of those is just where you the server side of things where you push stuff. So this is all working locally. So all these commands are going to be agnostic to.
But those services, they're just running vanilla Git. So whatever you do, you can push there just the same.
Right. Right. Okay. So this is fairly common scenario that you start working on something, you've done a lot of work on one feature branch, and in comes your boss and says, you really need to fix this. So you create a hot fix branch, and then you forgot they already did a bunch of stuff here. So you want to rewind this f commit and put it on top of master. So again, it's rebase to the rescue. So in this case, we just say feature one onto master. So this is the same syntax as in the previous example. It's just we have different starting points. So rebase feature one will take all the commits that are coming after that one. So in this case, just this f commit, and it will put it on top of master, which is here. So we go from here to here. So these have the same deltas compared to their parent, but they're going to have different contents because this commit has all of these changes in it, whereas this one does not. So now, if we start doing something and then we realize a commit that is way back, we need to make a change to it. In the case where it's a top commit, it's easy to just do a git commit amend and change it. But what if you have this? You worked on stuff here, and in this e-commit, there's a change that you really need to make a fix for. Let's imagine you were mad at the time and you put some poorly chosen variable names, which might have happened to me at some point. So you want to go back and change that before anyone else sees that. So let's say that we create something. So I guess use your imagination. So we have, so similar, git log p will, in addition to show you the commit messages, it will also show you the contents of your commits. So bad word here, and then you start changing the README. And I mean it. And then you look through your history and you're very proud of your instructions to not put bad words, and then you realize, I did it myself. So what you want to do in this case, again, this is a case for rebase. So in this case, we're actually going to do the interactive version of this. So you say git rebase minus I, and then this e caret will be whatever is the parent of the commit you want to change. So again, you can either say e caret here or d. They will resolve to the same thing. So what Git will do at this point, it will temporarily make your head be detached at this point and let you commit an update to this, such that you can change it and no one has to know you put in a bad word. So let's see how this works. So the commit that is bad is somewhere. Okay, this is the commit. So we say Git Rebase minus I for interactive, and we tell it where do we want to start it from. So if you're using Z shell and you really want to use the caret, you can put it around single quotes like that, or you can just do the tilde. They're the same when you have just one commit. So it will give you this this editor here, and you have a bunch of different options for each of the commits. You can say pick, which will just reapply them. Do nothing with them, just roll with it. You can do reword, which will let you change the commit message that goes here. So if you spot some spelling error in your message, you can fix it up here. You can do edit, which is what we're actually going to use. So we want to take this one and say edit. You can do squash and fix up, which will take the previous commit and turn them into one, which is good if you have, say, 20 commits and you want to kind of group them into logical units. So you can turn 20 commits into 3 commits that make some amount of sense. But in this case, we're just going to edit the one. So what Git will do is we're going to end up in this detached head state, and we can take our file, and instead of the bad word, we say a good word here. We do an add. But now, since we're rebasing, we don't want to actually commit it. We just want to say Git Rebase continue. Now we have a chance to do a new commit message if we want to, but this is a good one. And now the history will never show that I put in a bad word, because I put in a good word. So somewhere here I have some slides. So a lot of times when I do stuff, I will end up lose some work because I'm doing Git Reset when I shouldn't, and I wonder where all my work went that I spent so much time on. Git is pretty helpful in that it keeps the old commits for 90 days until you garbage collect. So in this case, we're on a feature, and we go to lunch, and someone decides, we're going to do a prank on this guy. We're going to remove his branch. He'll never notice. So I have these 3 commits. They're nowhere to be seen. In this case, I'm fortunate enough to see this. So they removed my commit, but I see that it was this commit. It was actually these. This is the SHA, or the commit ID of this commit. So let's create a new branch. So let's imagine, for instance, we're doing a calculator. That's always a funny exercise. So we do some functionality to create an add function. So we take our app, we say, this is probably horrendous JavaScript code, but I'm good with that. We have something that takes 2 parameters and add them. Oops. And I'm very proud of this code. So I commit it, and I go to lunch. So while I'm at lunch, for some reason I didn't lock my computer or what have you. So they check out master and then remove my add branch. So I come back and I see that they pull a prank on me, but the last laugh is on them, because I can take this commit message and just recreate my branch. So git checkout minus b, name of the branch, and the commit ID. And we're back in business. Now, if they're slightly more mean to me, which probably would be the case, they would clear the screen. So if I don't know how to scroll up, or if they, or if they turn off my computer in between, I have the ref log. So I can do ref log, and I can see. At this point, I committed my my commit that said edit stuff. So I can again just take this commit and create a new branch. And again, I have my stuff back. I can add stuff. But if for some reason they cleared my ref log and they're very, very mean to me, or if I don't remember this reflog command, there is a command of last resort. You can do git fsck lost found, which will walk through your object, all your objects, and find any object that is not referenced anywhere. So any commit that doesn't have a branch, or any blob that doesn't have anything pointing to anymore, all of those are going to be ending up here. So in this case, you have quite a few. So you would need to kind of go through each of these and see what they contain. But Git is
These are what are going to get cleaned up with garbage collection?
Eventually, yes. So before you turn on the vacuum 90 days later, if you do this git fsck lost and found, it will create a folder for you called git lost found. And in this case, it has two folders, one that's called commit and one that's called other. So commit has commits and other has the stuff that is not commits, which typically are blobs. But what we can do is do git log star inside this folder. And if you add the p flag to git log p, we'll see all the changes that any of those commits added. And we can, so if we know that we added a var add function, we can find that here, and we can go up and see that this is the commit that created it. And again, we can get back our work. So even if you try really hard to screw someone else up, as long as you have the Git folder and they haven't messed it up too much, you can usually get it back. This can also be used, for instance, if we have, so if we take, so for some reason we decide this README file is the best place to put my new novel. So I write a new novel here. Once upon a time, blah. And I ended with turtles. And so if I add this to the index, or I'll just do git add dot, for instance. And then I realize I don't want this to be in this novel to be in my README file anymore. So I haven't committed it anywhere, but since I added it to the index, Git still knows about it. So if I run this fsck command again, this will be inside git fsck, git lost and found rather, other. So in the case of blobs, Git will just write the contents of the blob. So you can just do a less star here, and it will show you that this file is just empty, I guess, whereas it has this additional file that has my novel. So if you do a lot of changes back and forth, this is going to be quite a few files. But if you know roughly what to look for instance, turtles, you're likely to find it. So are there any general questions about common, more or less common issues? So I have a bunch of examples of really crazy stuff. There's more hardcore if you run out of questions. But I think this is a good time to do more common But anyone that has had any Git issues in general, feel free to share and don't be shy.
It's the thing I thought about it a few times since learning about the 90 days expiry date. Is it possible once a year? Different than 90 days? Maybe
Yes.
like forever or short?
I think you can do it forever. It's in Git GC. So somewhere, yeah. So for one, you can turn off the automatic garbage collection. That will make it such that you'll never run it automatically. So that is a good first step. So that if you do that, you only need to make sure you don't run Git GC yourself. Other than that, so I think it's in Git config. Should have some sort of reflog. Reflog expire is one. Default is 90 days. So you can. I'm not sure if there's like unlimited, but if you give it some insanely high number, you're probably good. Yep.
So for the rebase issue, what if it's pushed and merged?
Yes.
And you want to, rebase?
Then you need to find all the people who work with this code and convince them that we should do this, because if not, they might throw hard things at you. It's very likely you're gonna get a merge conflict, and then you're gonna end up with the stuff in your history anyway. So yeah, if you do that, you need to coordinate it with whoever has already consumed the stuff that you pushed. Let's go here first.
Question about merge conflicts. Exactly.
Yes.
Especially if you choose a long-lived branches and you start
Mhm.
merging back and forth, and you just finish all the
Yeah.
merge conflicts and you commit it locally, and you get the next bunch. So how do you handle these things without going insane?
So the obvious answer, which you don't want to hear, is you shouldn't have long-living branches. But if you do, some ways to mitigate it is you have this Git re thing, which will kind of track your merge conflicts and which one you want to actually apply. So you can replay your conflict handling. Other than that, depending on how ugly you want your history to be, you can start merging the branches back and forth, kind of, to get less stuff in. I typically tend not to favor that. If you do insist on having a long-lived branch, I suggest you rebase it from wherever you start out from every so often, so that you stay in sync that way. Well, you rebase before you merge, or you rebase instead of merging, I guess. So that will effectively bring the stuff together anyway. So either if you rebase or merge, you're going to have merge conflicts.
Does that wind up doing a squash if you rebase?
You can tell it to if you want, but it will not do it by default now.
So sorry, I would rebase first the latest which I would get. Is what you're saying?
Yeah, you would fetch and rebase. Typically, you have some feature branch based either on like develop or master, depending on how you do stuff. So yeah, rebase on that as often as possible. I think Dave had a.
Yeah. With all these means of changing history,
Yes.
is there potential that this could be abused by changing history for a repo that did not have things changed?
I think the short answer is yes. And so please push responsibly, I guess. But yeah, I think you want to make sure that you limit access to who can make pushes. So whoever can push can make all sorts of weird stuff of the history. So I'm not sure if there's a good way around there, other than having signatures on commits or tags. I think that this is more an issue on something that's open source. If you're working in more of a, I guess, closed source is not as big of an issue because then you have typically stricter control as to who can push. But if you if you are in an open source project, you want to make sure that you trust people and review their pull requests or what have you before you merge. So yeah, that's a good point. Make sure people don't add bad stuff. For one, there was I want to say about 2 years ago, what have you, there was an interesting bug in Git where you could somehow inject config, because Git would let you store a file. Typically, you have these .git folders, but on OS 10 and Windows, you have a file system that by default is not case sensitive. So what you could do is do like that, and add files that way, and they would end up in your. So you could have a file like that, which could potentially lead to all sorts of interesting stuff. So yeah, please be careful with what you merge. I hope that answered your question. Yeah.
Follow-up question.
Yes.
On branches.
Okay.
What's your recommended way of basically working together on the same feature? Everybody gets their own branch, and you hope you merge back and forth.
So there are some different ways. If you have that, I would suggest you kind of define some sort of common ground that you both. If you need to finish something before you kind of branch off on that, I would say create some sort of branch that we do the common work and finish that, and then start to branch off. If that makes sense. So do all the things that is needed, that is common to both of the teams or all of the teams, and then once that is done, branch off of that. Other than that, I would say rebase as much as possible to keep the history clean.
But one branch or rebase then?
Yes. Sure. More questions? Or are people just very eager for my weird chainsaw? Yeah.
So for Git Bisect,
Yes.
does that just follow the branch as the parents, or is it branch agnostic?
It will figure out. So you give it a start and end point, and if it is branched, it will ask you additional question like which side of the branch has the issue. So it will work with branches as well. So I'm.
Situation where I'm not too sure how to use it, but we got to the point where we got basically to where the branch was created. Couldn't get
Go
past
farther.
that,
Yeah.
Figure out what the issue actually had produced.
Yeah, somewhat. Yeah. So bisect is a whole other. So I'll actually show you this. Yeah, it actually is. So I have this interesting. So there's I'll show you a teaser of it if I can find it. This one. This is a real life example of a bug in. So if I do view single. This is a bug in Backbone. So there's a version here that we know is that is good, and all the way here it's bad. So this is how Bisect works. You give it a good one and a bad one. It will find a commit in the middle, and you tell it, is this good or bad? So in this case, it's good, so we can assume that all of these are good as well, and so on. So even though this is roughly, I want to say, it's in the neighborhood of like 800 commits, you can do the Bisect in 10 steps. So cut it in half, even more in half, more, 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 and finally we find the bad guy. So this commit is bad. And I have another talk that goes into more depth of this. This is all effectively, if you go back to the original here, the starting point, this is version 0.52 or something like that, is the green one. We know that that one is good. And this is 0.7, I think it is 0.9 or something like that. So we have two point releases, or two versions essentially, that we know are good and bad respectively.
But they seem to be spread across multiple branches.
Yeah.
It finds its way through the right.
Yeah, it does that. So it has a long history of being branched back and forth, not back and forth, but it has a lot of merges. But it's Bisite is smart enough to figure that out, and it will find the actual bug. So yeah, Bisite is one of the most underutilized tools of Git, I would say. Probably up there with Rebase.
Sorry, after finding this right now, how would you fix this? Because it's pretty much not in the middle bug.
It's a big part of the resolving issues is finding what caused it. So in this case, what happens in this bad commit? Once you know what the bad commit is, you can go. If you revert that commit, you have a fix for. You have a bit of a fix for it, but at the same time, you probably end up with some functionality that you don't want to lose out on by fixing it. But what you can do is you can take that revert and undo incrementally that one commit. Especially in a language like JavaScript that you don't need to compile. This is handy. So you can just take piece by piece that commit and undo the changes. In this particular case, you can narrow it down to the single line that is causing the bug. How are we on time? 7:53? 23. We have about half an hour left, I guess. That was according to schedule. So I'll show you what this looks like. Actually, a quick overview. So this is an issue that only occurs in Internet Explorer 7. So if you still have this issue, why are you still using it? IE to begin with, but it's 7. So in this case, we have we might not be able to do it. I think this is quite possibly the first time I ever wanted IE7 to actually work. Okay. Let's try again. So if this doesn't work, you have to take my word for it. Graphic. Discard. Boom. Sure. I haven't used it in a while. This was probably part of the problem. I'll give it one more try. Okay, it works. So, does anyone have IE7? Thank you. Guess there's some, yeah. So that's somewhat unfortunate, but yeah. On that note, let's do some crazy stuff, I guess. So everyone's favorite app or framework is Rails, right? So one of the things, it's an awesome command called filter branch. So if you think that Rebase is hardcore, this is taking Rebase and multiply it by 9,000 or something like that. This is the Git equivalent of a chainsaw. It will quite literally chew off your feet if you let it. So in this case, I'll show you some examples of what you can do. So one of the most loved/hated things in Rails is the whole asset pipeline thing. So let's say that we want to just get rid of the asset pipeline entirely and nuke all of the existence from the history. We just want it gone. So Git filter branch has a bunch of different kind of filters, and I'll go through a few of them. So the one to start with is called tree filter. Tree filter will take, you give it a command here, and it will run that command against all the ranges of commits that you give it, and it will create a new commit based on the what that commit did. So you can do pretty much anything that changes the tree here. So for instance, if you say just echo, it will not do anything. In this case, I need to add the F flag because I did this before. For F is for force here. So because filter branch is a chainsaw, it will try to keep yourself from chewing off your foot. But if you don't care about your foot, add the F flag here. So then you tell it what range of commits to delete from. In this case, if you say just master, it's going to do everything from master, or from the beginning of time until master. So you see, this is going to take forever. So but I'm guessing you don't want to stay 2 hours to just see this run. So instead, just say we want to take the last 200 commits, and this will do the same. So because we're running echo now and actually not doing anything, this is effectively a no op and a waste of time, really. So let's do something more interesting. And instead of just saying echo, we want to find this asset pipeline business. What's that? Right. So RMRF, and remove the assets. So this will take roughly a minute, which I guess we can wait. Any questions while we wait for this? It runs this command regardless. That's why you need to add the F flag, and R will make it recursive. So if the file doesn't exist because of the F flag, it will just be happy anyway. So the F flag is the kind of the Prozac for RM. It's rewriting history, yes, and very much more so than the Rebase. It will. This is kind of, so if Rebase is somewhat gentle, this would be. It's actually one of my slides. This is what kind of what it looks like. This is pretty much what you'll end up with if you're not careful. So now we see Rails types is no longer here. No more asset pipeline. Does it show that in your ref log? Yeah. So it shows quite a bit of stuff. Not quite, but quite a few. It would show you like before and after. So now in this case, git ln is my way of saying git log name status, which will include the file name. So if we search for asset, we're going to see one commit here that has a bunch of deletes. And that is the one that's 200 commits back in time. So that one will appear as if this was, up until that point it existed. So if you had more time and you said just master, it would nuke all existence. But in this case, all the 200 top commits are freed from assets. So anyone who you work with is probably going to get very mad at you. Yeah. So. Yeah. So yeah, typically this is a good thing to use when you start off a new project and you want to take bits and pieces of other repos and say you have a subdirectory of some project, you want to base a new project off of that and have the history, but only the history of those particular pieces. You can start off with just the commits that pertain to that part. So it's a bit of an edge case, but it's when you need it, it's kind of handy. So this command is somewhat slow. It took about a minute. There is a slightly faster command if you're able to use Git commands that work directly with the index, called index filter. So in this case, we can use git rm, let's say cached. So git rm cache will only work on the index. It will not actually remove any files. So here we also want it to be recursive. And similar to the F flag for the normal, I should go down here. Similar to the F flag for the normal Git, there's a ignore unmatch that you can use for the git rm. So now this is not going to do anything because we actually removed it. But say that we get all the stuff back from the origin master and run this again. The other one took roughly 1 minute. This will be cuts it in half roughly. People are walking by here and having no idea what's going on, I guess. What is this epileptic thing? So same thing here. Way back when we have a bunch of deletes of assets. So if you can get away with it, index filter is a lot faster than tree filter because you don't need to check out files and compare what changed. You work directly with the index. One more filter I'll mention is message filter. So message filter will take your commit message and run whatever you want against that filter. So since Rails can be a somewhat loud of a community, let's reflect that by changing all the lowercase a to z to uppercase a to z. And this is quite a bit faster than the index filter. And here be yelling. And again, this only goes to the top 200. Eventually, people are getting less loud, quite a bit in the past, somewhere. Let's search for. Here we go. And so. Yeah. So filter branch. So tr will change A to Z lowercase to A to C uppercase. And if you do the other way around, you can make, that's not quite what I meant. That's what I meant. That will make it go the other way. So now it's a, that took longer, it seems like. I will make it a little more quiet. So typically, this is not particularly useful, but there are cases where you, for instance, have a repository full of bad words and you want to publish it publicly. Then it could be good to do some sort of cleanup. Similarly, you can take the committers. Say, for instance, you want to make them anonymous. So you can replace whatever the author is with anonymous. So that one is called env filter, and I think it's called git committer. I actually don't remember what it is.
So when you use the TR,
Yes.
that's a command that's part of filter branch.
That is a
Calling out to the,
it's calling out to the shell. So TR is
but git committer, for instance, is not calling out to the shell. Or
right. So this is this will take anything and just anything you can do in a shell you can use as a message filter or any of the filters really. So committer. I actually don't remember what it's called. This is one of those things that you typically don't use. It's like Git. Reset author it's similar to it, but it's not quite the same. That one, reset author is more. It's so you have the notion of plumbing and porcelain in Git. Porcelain is the higher level stuff, and the plumbing is the more low level. This is a low level command. So whereas the commit with the reset author is more high level. Git committer email seems to be the one. So if you say git committer email up here, so just take the last 10 or so. So git committer email, and I will say git author email are the two that you want to change. So now, now all of them are called hi. And similarly, you can change the git committer name. So hi mom has done a lot of commits. So this is handy if you have a lot of commits that you want to share with someone, but you don't want them to know who actually did it. It would appear that all of them are done with this weird hi mom. So I think that is roughly the content I had. So again, any additional questions, feel free to. Yes?
So question was resetting the branch from different levels of basically screwing up and how you recover.
Yes.
It's very nicely easy to really the hard reset you did. So my question was always when you reset, how much is actually reset and how does it work? Online is always do this and it will save your world. But I never got why and how much I'm losing.
Sure. So if you say, again, this is a good time to watch that video, but I'll give it the synopsis of it. So if you do, where are we? So say for instance we have this one file, we add something here. So now it's in the index, and it's also in the working directory. If you were, say, just git reset, it will read the index from the previous commit. Basically, it will untrack all the things you did. So it will get back to this state where it's the file is changed, but it's not staged. If you do git reset, this is the same as doing git reset mixed, if I can spell it correctly. So mixed is the default. There's also soft and hard. They differ in, so mixed is the in-between. The soft will leave the index. So if you do git, if you add the file again, and say git reset soft, it's a no-op. If I could spell status, it's a no-op because you're not changing the index. The index is still the file is still added in it. This. The point of soft is you can give it a commit here. So this is handy for one way to do. Let's say, for instance, let's go back to the Rails. I always like to mess up their code. So in this case, reset hard will take whatever is in this origin master, and it will read the working directory and the index, and it will set my branch to point to the same thing. So we'll do all of those three.
No, but origin's a remote there, so if you screwed up your master, does it just get rid of your master?
So origin in this case is actually what's called a remote tracking branch. So it's in this list. So even though this is a very cute branch name. So the origin master is going to point to the same thing until you do a git fetch. So this will repoint whatever branch you are on to match what is on the origin master. What is the latest that you're aware of from origin. So that is what that command will do. The soft command will let you do so git reset soft. So let's say we take head and go back 10 commits, something like that. So what this will do is it will take all of those 10 commits and it will leave the index, but it will put the branch back to be the parent of the 10th parent. So effectively, you will have all of those 10 commits staged, so you can do one commit to commit them into one. It's one way to squash. So that will take the 10 top commits and squash them into one. So that is probably the best use case for soft. There are probably some more, but that is the one that comes to mind. Similarly, hard as aforementioned. If you want to, there's two ways to do this. Either you can just git reset hard origin master, which will get you back to that. You can also do git checkout -B. Say master origin master. That will recreate your local master branch to point at the origin master. And the capital B as opposed to the lowercase b will override any existing branches you have. So that will cut out a so a lot of the time people tell you to check out this and then remove the branch and check it out again. This will do that all in one step. So if you want to go hardcore and recreate your master based on the origin master, this is the command to do. Yep. So the equivalent to branch, if you want to create a new branch. So by default, if you have a branch foo, you say git branch foo, it will complain. So the equivalent of the capital B in the case of branch is F. So that will create a new branch even if it exists. So git checkout minus capital B is the equivalent of doing git branch F instead of just git branch. If that makes any amount of sense. Any other questions? I will probably need some more water. So you have any? Does anyone have any water, or are we done with questions?
We'll see if I can find you some.
Okay. I can push through if anyone has any more questions. Yeah.
Last one on
Detached head. Yes.
I don't really fully understand what it really means and how you fix it. I have a rough idea, but
Yes.
something the recommendation are.
That actually. So my biggest recommendation is to always make sure you have your current branch in your, that you can see your current branch in your shell like that, so that if you were to get a detached head like that you would be aware of it. So if you see weird numbers and letters instead of your branch, you know you're in a detached state. As for fixing it, let's say we change some stuff here.
Does it actually mean?
Oh, it means, let me actually explain that.
Might be easiest to show it on the graph.
That might be, yeah, I have it somewhere here in the past. If I can never remember the, like this one. So here would be if you're, so let's say here you're at a point where you have, this is a attached head. It points to this particular branch. What detached head means that your head is, instead of pointing to a ref, a branch of sorts, it's pointing straight to a commit. Thank you. It's basically being on an unnamed branch, I guess you could say. So you're not on an actual branch. So what it looks like under the covers is, in the case of the normal case, is you have this git head file, which will point to a ref like that. So it will point to ref's head master. This is actually the fully qualified name of master. So whenever you type master, this is really what you mean. You mean ref's head master. You can do all sorts of logs and whatnot. So this means that head is pointing to this, or if you check out a different branch, this will point to that branch instead. If you were to do a detached head, what it points to is, rather than a ref, it points straight to a particular SHA. I'm not sure if that made any amount of sense, but that's what happens.
So that raises the question, can you view all of your heads?
You only have one head. This is not the Hitchhiker's Guide to the Galaxy. We can have your second head. Well, I'm not sure what you meant by head in this case.
I guess it's a head per branch, right?
So it's actually, so the terminology is a little weird. So in Git terms, I would say the head can mean two things. It's either the commit or branch you're currently checked out, or it could be whatever the head is on the remote. And the head on the remote is the default branch. So if you were to do so let's say we have a product on GitHub and you git clone. If you don't specify a default branch, if you don't tell it which branch you're actually interested in, it will give you the branch that the GitHub has selected as a default. Let me actually show what that looks like. I believe I have some sort of public. So my slice repo, for instance. This editor. If I were to commit I can't type today. If I commit this, I create a new branch on here called SEM for, I guess let's call it SEM.js. So you can rename a branch by using the M for, and the mnemonic is M for move. So SEM.js will take your branch and rename it something else. So I actually have two branches. So if I want to remove the other one, I can say delete SEM. That's not how you drink. But if I were to clone this now in a different repo or different location, I would still get, it would still point to master. But somewhere here you can tell it what your default branch is. And settings. What's that? Branches. Ah, there you go. Yeah, this is a default branch. So what this does is it will update the head. So if you do git ls remote here, you see that the head actually points. I guess I didn't save it yet. Yes. So it will change. The head will point to SEM.js now instead of master.
So there's one head per repo?
There's one default head per repository, correct?
There's a video called Git where you just pour it up,
Okay.
which uses like link logs to demonstrate this, and it literally like has a one head pointed.
Yes. Please watch that.
Yeah, it's pretty funny.
Yeah. And now we're back to being on the master. But yeah, the head is, you have typically exactly one head per repository. And that is, in the case of your local repository, it's whatever you're checked out at. In the case of a remote one, it's whatever the default is, what you'll get if you clone it.
So to come back to fix it, I would check out basically the right branch.
What's that?
Sorry, for fixing the detached head, I would just check out the right branch.
There's some ways to do it. I would say the best way to do it is, so if we go back to Rails, for instance, so say we create a commit here, and hi. The best, get add p, hi. Some weird commit. I would say the best way to get fix the situation is to create a new branch, like that, git check -b, and call it whatever you want, something. That way you get a branch. It might not actually point to the right thing, but at least now you have a branch that you know where you're at.
It contains all the things I had there.
So whatever the state at the detached head was is now has a name. So I think that is probably, unless there are some 5-minute more questions. I have one more.
Will you have that to show us a bit of the splitting and merging of repositories?
Yes.
Will you have that?
Yep. Absolutely. So in the case of Rails, let's say that we are interested in, let's go back to our origin master, and call, actually, go back here. So we are, say for that we're interested in just active records, for instance. So we want to create a new repository that has all the history, but only the pieces that pertain to active record. You can do filter branch. This one is called subdirectory filter. And then you just give it the name. I want to say that's what you call it. Maybe subdirectory. Yeah, that will do it. This is going to take quite a while as well. Not as long as the others. So this will create a new commit that only has that subdirectory, and that subdirectory will be the new root of the repository.
So does that mean that you would be able to take that subdirectory or whatever the output of this is as a completely standalone repository?
Correct.
Wow. So the reason I asked partially is that I have a project where I have a lot of utilities that don't depend on each other.
Yes.
And I don't want to have a heavy footprint, so I would like to be able to split up and
Okay. Yes.
repository. That's something that's straightforward to do?
It's relatively straightforward, yeah. So filter branch will let you do that. In that case, you probably want to add the prune flag, which will basically remove all commits that have no contents. So because of you only care about one subdirectory, any commits that only touch others are going to show up as an empty commit. The prune flag will get rid of those. Any other questions, or are we good to go to the, not the arena, but the other place? I think let's get out of here, has it? Thank you all for coming.